ప్లే చేయండి.
NEET 2025 didn't go as planned.
535 मार्क्स, बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P2CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello my dear students, good afternoon. How are you all? Welcome to one more amazing session from Infinity Lane. How are you all doing? Please confirm, can you all able to hear me and see me? I want to see the chart. Yeah. So this is a session all about, we see the stoichiometry and stoichiometric calculations, and today's topic of interest is going to be the concentration terminologies. And this session is especially benefit for the students who are preparing for NEET 2026 and a dropper ke liye, and is also benefit for you guys who are studying your grade 12 and also initially attending the 11th grade students, because this topic covers everything. And I just want to take this session in a different format. Hi Paramesh, hi, good afternoon. Now let us talk about when you prepare for your NEET examination, it's a lifetime dream a doctor banna kaise hai. Want to wear a white blazer with a stethoscope and proudly entering into a medical college. For that, Infinity Learn YouTube channel is going to give you a support, and eminent faculties are taking the classes every day. Please attend these classes, and a very good content is being delivered and it can help you a lot. And also we are offering certain programs where you can rejuvenate your preparation, like Atreya. So what this Atreya program? So this is especially for the droppers. So when you write this NEET 2025, if you done well, congratulations. And very good number of students, they study well and they prepared well but cannot made it. So we come up with a special program. We want to change your mindset from I didn't do to I will do it. Yes, by Atreya P2CB program. So students preparing for your NEET examination, common problem is physics. Infinity Learn want to come out of this problem. That is P2CB program, where you can prepare double for physics and along with C chemistry and B biology, right? So that is Atreya program, India's most powerful NEET repeaters program, and we proudly announce this. And let me tell you the importance of this Atreya. It is a revolutionary NEET preparation with P2CB program for the double focus on physics along with chemistry and biology. Description में एक link दिया, एक बार click करना and you can do it. And let me explain you the program details of this. And this program starts from May 23rd. कल शुरू किया and आज से आप enroll कर सकते हैं. And duration of each class is going to be 90 minutes बच्चों. And there are 3 classes per day. उसमें 2 concept classes होगा, 1 practice class होगा. And I want to tell you, these classes are designed in such a way that pressure will be given less on the student, and the knowledge gaining and the problem solving abilities will be increased because of these practice sessions. And you can say 18 classes per week. आप घर में बैठ के आप ऑनलाइन में ये कोर्स कर सकते हैं. And in the 18 classes per week, double practice classes for physics as well. And hope this can help you a lot. And you can see the features in this course. 465 classes, live interactive sessions by expert faculty, and also 240 DPPs, काम करना है, अच्छा करना, and also 120 plus hours of dedicated practice classes, उसमें physics का double होगा, and also after class, every class, the class notes is going to be converted into PDF and it will be sent to you. And batch size for especially for practice session जो है ना, batch size for especially for practice sessions, it is not in the dump, it is 20 to 25 students together a given a practice, ताकि आपको पता चलेगा फैकल्टी से बात करना है, क्या डाउट है आपका, कस्टमाइज्ड एक्सप्लेनेशन भी दे सकता है. So that is very important. If we dump you in a group of 100 students and giving the practice, it gives a lot of confusions. But if it is a 20 students or 25 students, you will be having a very good discussion with, you can have an interaction with an expert faculty, so that your doubt is going to be explained on the customized basis. Believe it. And also coverage of the total 11th to 12th, right? So this is very important Atreya program, and everybody please look into this. Link is given in the pinned messages in the chat box also. You can click it and you can enroll now. In the description box it is given. And when you want to do something, you explore properly and you can do it. And those students who are preparing for NEET examination, okay, they will be having n number of problems, like somebody will have the physics problem, somebody will have the chemistry problem exclusively, and the biology every student can do it. So one year drop can cost a lot, and we are going to take care of that, and your NEET result is on us. You can clear your NEET examination in the open category, in the premium, you can enter into the premium medical college. Can you believe it? And this is the path, you can do it. And also these are the program features I already explained, and I said it is Monday to Saturday class, every day 90 minutes each class, and there are 3 classes, 2 concept class, 1 practice session, right? And moving ahead, today's topic of interest is going to be on mole concept. थोड़ा सा revise करके concentration terms को जाना है. Ready? Ready? Yes, Ayush Kumar, 7E26, hello and thank you very much. And let's talk about, once you already did your NEET examination 2025, you can predict your what could be the rank and what could be the college predictor. Everything team is working on that. You can just click the link is available and you can go ahead with that, and automatic updates you are going to get it. And talking about a short recapture about the mole, I don't want to take much time of you for promoting the things and all. I just want to directly take into them. Today's agenda of topic is going to be mole concept. थोड़ा सा revision करके आपका concentration terms में ज़्यादा ध्यान देना है, and अगले क्लास के लिए आपके stoichiometric calculations भी देना है. Ready? One thumbs up and fire emoji before we start the class, my dear children. Make it fast. Once. Say hi everybody, so that the connect is going to be built between you and me. So what is a mole? Anything, yeah, anything which count for this big number, that is given by Avogadro, and this is called as Avogadro's number. Just a minute. Yes, coming. So anything which count for this big number is called a mole, and this is given by Amedeo Avogadro. And this number is called as Avogadro number, and which contains this many number of any entity, chemical entities or anything. And I said this number is 6.022 into 10 raised 23, and you need not have to use all the precision numbers. And when you solve this any type of question, simply you can write 6 into 10 power 23. So anything which count for 6 into 10 to the power 23 is called as a mole. I just want to say here you can say a pair means, one pair means it indicates number 2, right? 1 dozen means which indicates number 12, understand? And a century means which indicates 100. Similarly, a mole means that is Avogadro number, that is 6 into 10 raised 23, a number. I say a pair of apples, 2 apples. I say a dozen of apples, 12 apples. I say a mole of apples, 6 into 10 raised 23 apples. If I give you 6 into 10 power 23 apples, now it is going to cover entire globe. That much big number it is. That much big number. It is an awesome number. And a mole means which contains exactly the number of atoms in 12 grams of carbon 12. That is called sextillion. 602 sextillion atoms. That is called as Avogadro constant. This is also indicated as Na or N0, doesn't matter. In some books it is given as N0, in some books it is given as Na. Okay? And you can calculate a number of moles from the mass, from atoms, from the molecules, from the volume, whatsoever it may be. One mole means it could be equal to the molecular mass of the atoms, or it could be equal to molecular mass of the molecules expressed in grams. The molecular mass expressed in grams is called gram molecular mass. The atomic mass expressed in grams is called gram atomic mass. And it is also equal to the number of particles. Yeah, why only for carbon 12 is taken? So the carbon 12 is taken because it is the stablest isotope. It is a stable isotope. Even for the animals and the plant, carbon is the one element present in it. And the content and the quantity of the carbon 12 is always maintained constant. Hi Anisha, how are you? Very happy to see you. You attended my previous class. You asked so many questions. I really appreciate you. And that is the reason why there is a debate, as Ayush Kumar asked, why only carbon 12? Initially hydrogen is taken, but hydrogen has a number of isotopes. It is changing its the percentage composition in the natural samples. And also sometimes oxygen is taken, the same problem. Okay, chlorine is taken. But the thing is, somebody has to take some unified version. So IUPAC is everybody accepted that C12 is taken to calculate the number of moles. Okay. Now talking about the mole. So the mole can be calculated from this mass. For the atoms it is said to be gram atomic mass, and for the molecules it is said to be gram molecular mass. The mass of 1 mole of molecules expressed in grams is called gram atomic mass. Okay, thanks. And it is going to be count for any atoms or molecules, electrons, protons, ions, anything. It is 1 mole means it is equal to, it's a Avogadro number. I said Avogadro number of apples means the collection of 6 into 10 to the power of 23 apples. It could be chocolates, it could be atoms, it could be molecules. So the simple thing I just want to give you, if you want to go ahead with mole calculation, just say atom or a molecule or ion or electron, whatsoever it may be. Don't fright about these terminologies. 1 mole means Avogadro number. It could be equal to that. Okay, talking about the gases. At standard temperature and pressure, 1 mole of any gas occupy 22.4 liters. 22.4 liters at STP. What is this STP, dear? यार STP और NTP इसका आ सकता है. It is temperature जब आपको 273 Kelvin होगा, and it is going to be pressure is equal to 1 atm होगा. 1 atm nearly equal to 1 bar, right? and STP NTP दोनों सही है. So 1 mole of the substance appears like this beta. 1 mole. Atoms are such a small things. Atoms are such a small things. Okay. If I take 1 mole of apples, na, apple is a big thing. 1 mole of apple, it covers the entire globe. That much big it is. When it comes to the molecules or the atoms, they are such a small number, small size. When it is talking the copper, okay, carbon, if it is a carbon, so Avogadro number of carbons appears like this only, this much, right? So you can take a zinc real-time visualization. आपका 1 mole of the element कैसे लगा? Okay, sulfur powder 1 mole ऐसे दिखते हैं आपको. 1 mole of silicon appears like this. 1 mole lead appears like this. 1 mole tin appears like this. 1 mole copper metal. Where you see copper metal? In the copper wire appear like this. 1 more magnesium metal appears like this. Actually magnesium metal powder के जैसे नहीं होगा, magnesium ribbon के जैसे होता है. And the carbon powder, it could be coal, coke, whatever it may be. Okay, and it is 1 mole of zinc is appearing like this. So feel it. I want to give you a very good suggestion. So when you want to study something, you feel it, you experience it, ताकि आपको कनेक्ट मिलेगा. Otherwise some numbers doing calculation, जो भी कैलकुलेशन आपको आता है, एक कैलकुलेशन पकड़ के गलती आंसर होगा. Okay, just yours, I'm yours, take care. Okay, now talking about important note, where a mole concept is, you feel it is easy, but you are going to get some confusions. I want to let you know what are the confusions. Sir, in real life, can we able to see atom by any instrument? Ayush Kumar, you can't see atom by any instrument, but you can see the image of the atom. Image of the atom. Image of the atom means you can see the pattern of the image, that is nothing but spectrum. Got it? Ayush Kumar, it's very nice to that you are asking a doubt. And Anisha, hi Betty, how are you? Important notes, STP and NTP conditions and standard conditions means the temperature जब 0 degree होता है, yeah, and 273 Kelvin, both are same. And the pressure is 1 atmosphere or nearly 1 bar or 760 millimeter mercury is said to be standard temperature conditions. And it काफ़ी important है, 1 gram atom is same as that of 1 mole. 1 gram, जब 1 gram atom term आना है तो आप 1 mole मान लो बस. ठीक है, that's very important. That is very important. And hence will have the weight equal to atomic weight expression grams is called gram molar weight. That is called gram molar weight. Gram molar weight or gram molar mass. You have given a lot of differences between the mass and the weight in the physics. But in chemistry, mass, weight, दोनों एक ही है. Anjali Singh, hi. Okay. Now, 1 gram molecule is same as that of 1 gram molecule is same as that of 1 mole of the molecule. ठीक है. So that is called gram molecular weight. Gram molecular weight. That's very important, bachcho. Okay, and where you can see here 1 gram ion means the 1 mole of the ions is called gram ion. Similarly, I just want to say, remember this is a dangerous point I just want to give you. So this is a point which I can take you out of the danger. I don't mean to say this is a dangerous point. Okay, this point is going to take you out of the danger. ये क्या आप डेंजर में है क्या? हाँ, अगर कुछ थोड़ा सा हल्का सा डाउट दिमाग में अटक गए तो डेंजर में ना. एंड दिस पॉइंट कैन टेक यू आउट ऑफ द डेंजर. Ayush Kumar, I means we can assume that in chemistry the mass and the weight is equal because atom is very small. Yes, of course. अरे फिजिक्स में वेट एंड मास फ़र्क पड़ता, लेकिन केमिस्ट्री में ऐसा फ़र्क नहीं आएगा. जब आप वेट इस्तेमाल करो, मास इस्तेमाल करो, द टर्म इज सेम, एक ही मीनिंग आता है. आयुष कुमार, ठीक है बेटा? ठीक है, गुड. नाउ लेट अस रिमेंबर 1 ग्राम एटम अलग है बेटा, 1 ग्राम एटम अलग है. 1 ग्राम एटम, 1 ग्राम एटम, 1 ग्राम ऑफ एटम, ये इंपॉर्टेंट चीज़ है, ये इंपॉर्टेंट चीज़ है. 1 ग्राम ऑफ एटम का मतलब मीन्स आई हैव गिवन यू एटम ऑफ 1 ग्राम्स, 1 ग्राम्स. ओके, सो 1 gram hyphen atom means it is equal to 1 mole of atom. This is 1 mole of atom. This is 1 mole of atoms. Are you getting or not? Clear beta? Any doubt? This is 1 gram means it is 1 gram only. 1 gram mole, this is otherwise called as 1 gram mole also. 1 gram mole. Meaning of this is same. Yes, and this point can take you out of the danger. Believe it or not? Believe me. And also example, x gram atom of nitrogen is equal to x mole of nitrogen. Anisha, that is equal to x into Avogadro number of nitrogen atoms. है कि ना? X into Avogadro number of hydrogen atoms, nitrogen atoms. Similarly, x gram molecule of nitrogen means x mole of nitrogen. Each nitrogen molecule का 2 hydrogen nitrogen atoms होगा ना, that is equal to 2x into Avogadro number of nitrogen atoms. And this give you a lot of insight for calculation of the number of moles. Take a snapshot everybody. Snapshot everybody. Taken. 3, 2, 1, click. Screenshot ले लिया. And calculation of moles, you have calculation of moles 3 तरीका आता है, 3 तरीका, type 1, type 2 and type 3. So type 1 कब इस्तेमाल करना? जब आपका mass of the substance दिया होगा तो. It is used when mass of the substance is given. Mass of substance is given. टाइप 2 कब इस्तेमाल करना? जब नंबर दिया तो. इट इज यूज्ड व्हेन नंबर इज गिवन. when number of particles are given. ओके, एंड नंबर ऑफ पार्टिकल्स का मतलब मान लो ये एटम्स हो सकते हैं, मॉलिक्यूल्स हो सकते हैं, आयन्स हो सकते हैं, इलेक्ट्रॉन्स हो सकते हैं, प्रोटॉन्स हो सकते हैं, अल्फा पार्टिकल्स हो सकते हैं. ओके, सो एनीथिंग इट कैन बी. एंड टाइप 3 कब लेना? इफ मास ऑफ गैस इज गिवन, इफ वॉल्यूम ऑफ गैस is given, if volume of gas is given at STP, at standard temperature and pressure. So STP, I will come back what is STP and TP again. Let us talk about when mass of substance is given. Number of moles is equal to weight of substance upon gram molecular weight. So you know the molecular weight, sum of the atomic weights of the molecule is called gram molecular weight. समझ में आ रहा है कि बच्चों? Clear? So is that visible to you all? Is that visible to you all? So is there any blur is coming? Okay, fine. It is perfect. So let us talk about type 2. That is, yeah, it is clear. When number is given, number of moles is given upon number by Avogadro number, number of given particles upon Avogadro number, 6 into 10 to the power 23. This is the second one. This is the first one to calculate the number of moles, and this is the second one to calculate the number of moles. समझ में आ रहा है क्या? Anisha, And talking about yesterday we did this, and I just want to recapture this, okay? And if the volume is given, number of moles is equal to volume of gas only for gas at STP expressed in liters upon 22.4, it is liters, expressed in liters. You want to do in milliliters, number of moles is equal to volume of gas at STP in milliliters is equal upon 22,400. This is another way, okay? And let us take the combination of these. You want to calculate the weight now, you can simply take the weight. Here weight of the substance is equal to number of moles into gram molecular weight. So I can calculate the number of moles. If moles is given, I can calculate the weight as well. Similarly, you want to calculate the number of particles here, you can calculate by multiplying number of moles into Avogadro number, 6 into 10 raised to 23. Are you getting or not clear? Right. And volume also, volume in milliliters is equal to number by 22.4 liters, 22,400, okay? So these are the various versions of the formulas. Let us take these type 1, type 2 and type 3 in the combination. When you take this type 1, type 2, type 3 combination, you are going to get number of moles is equal to weight of the substance upon gram molecular weight is equal to number of particles upon Avogadro number, it is equal to volume in milliliters at STP upon 22.4 liters, 22,400. It is going to be 22,400. And this is a super powerful formula, my dear children. When you do this super powerful formula, you can calculate if weight is given, number of moles can be calculated. If number is given, you can calculate the number of moles. And volume is given, you can calculate the number of moles. If weight is given, you can calculate the number. If volume is given, you can calculate the weight. Everything is possible from this. Sir, I have a doubt. You said it is at STP. If it is given at STP, okay, standard temperature and pressure. STP में क्या होगा? Pressure is equal to 1 atm and temperature is equal to 273 Kelvin. Okay, now I just want to say anything is not given at STP. आप STP में convert करना का क्या कर सकते हैं? हाँ, 22.6. Anisha, you can take 22.4. If it is specifically mentioned in that particular question as molar volume is 22.6, you can use this. Otherwise, you please use 22.4. Anisha, you got the clarity? You got the clarity, bachcho? Right. So, if temperature and pressure is not at STP, you can use P1 V1 by T1 is equal to P2 V2 by T2. So these two are going to be very, very important. You can use this. Just a minute. Right. Now moving ahead, concentration terms. Ready for that? Yeah. So today's topic of interest is going all about the solution. What do you understand by a solution? We just take a salt and add in the water. आवाज नहीं है अभी. आवाज आवाज आ रहा है क्या बेटा? अनिशा प्लीज कंफर्म, इज माई वॉइस इज ऑडिबल? Is my voice is audible? Please check, is my voice is audible? Ayush Kumar, is my voice is audible? Confirm. Thank you very much. Let's follow a solution. You take sugar and add in the water and it is going to be dissolved, and this is said to be a sugar solution. Salt, you add in the water, salt solution is formed. A solution is nothing but homogeneous mixture of two or more than two non-reacting components. If you add sugar in the water, sugar is not reacting with water, but it's just mixing. That mixture is homogeneous, uniform mixture. That is called solution. Okay, and in that एक solute होगा, एक solvent होगा, and a solution is equal to solution. I just want to say a solute plus solvent is equal to solution, and a solution can have one solute and one solvent. That is called a binary solution. A solution can have more than one solute also. That is said to be multiple, like a ternary and quaternary solutions. But here, as far as this NEET and grade 1, grade 11, 12 and NEET and any competitive examination is concerned, we talk about the binary solutions. So binary solution means a solution contain one solute and one solvent in it. Okay, let's coming to the discussion. What is a solute and what is a solvent? The substance which is getting dissolved is called as a solute, and the substance in which the dissolution takes place is called as a solvent. I'll explain you molarity. Molarity, I'll come back after talking about this. We'll discuss about the molarity, and I'll give you various things about the molarity as well, right? Lesser quantity, quantity Karim, quantity in terms of less number of moles, less number of moles. And it is going to be more number of moles. So that is called actually a solute and a solvent. Okay, now various types of solutes and gaseous solutions, liquid solutions and solid solutions. Gaseous solutions solvent gas होगा, liquid solution solvent liquid होगा, and solid solutions solvent solid होगा. Lesser quantities, yes, exactly. I am coming to the molality and various things later. Right now in today's class itself, a gas is mixture with a gas. It is going to be a mixture of oxygen and nitrogen gases is an example. Air is an example here. Liquid dissolved in a gas, like chloroform is exposed, so the chloroform vapors comes in the liquid state and it is chloroform mixture with nitrogen gas. And solid in the gas, it is a camphor is sublimated, so this is solid in liquid solutions. My dear children, here liquid solutions, you can see gas is dissolved in liquid. Yes, gas is dissolved, oxygen dissolved in the water, and also said to be carbon dioxide in water. Carbonated beverages is also another example. You drink in the summer, we drink soda, we drink Coca-Cola, you drink all carbonated beverages where carbon dioxide gas is dissolved in it, right? And liquid dissolved in liquid, ethanol dissolved in the water is an example. So follow here, solid can be dissolved in liquid. Everybody has this example. Glucose dissolved in the water. Okay, sucrose, table sugar dissolved in the water, salt dissolved in the water. Okay, and dissolution process is a big concept actually. And solid solutions, gas can be dissolved in solid. How it is possible? A solution of hydrogen gas is dissolved in the palladium powder. Yes, it is true. And liquid dissolved in a solid, yes. Sodium is dissolved in liquid mercury, so that is called as amalgam. My dear children, the term amalgam is important. Okay, amalgam means the solid metal dissolved in liquid mercury is called amalgam. Sodium amalgam, zinc amalgam, or amalgamated zinc. Zinc is so reactive, but the reactivity of the zinc is decreased by dissolving zinc in mercury, so that is called as amalgamated zinc, amalgamated sodium, right? That's a very, very important terminology. And you can see amalgamated zinc is used in Clemmensen reduction, where you can see zinc mercury amalgamated zinc, है ना? You can see that this is Clemmensen reduction में इस्तेमाल किया, organic chemistry में you are connected here, right? Now solid in solid, that is copper dissolved in gold, any kind of alloys beta comes under this category, alloy. So it is under this category. Any doubt? Any doubt? Right. Now let us talk about the other formats, components of the solution. Solution, the formation, solute and dissolved in a solvent, you are going to get a solution. So these slides are awesome, and especially thanks to the team, our PPT team is made these beautiful and awesome slides, right? Thanks to my team. And let us talk about the formation of solution. And a mixture where a components are uniformly distributed throughout appears as a single substance. And you can take this is a salt, it dissolved in the water, it is going to form a dissolved state. Now when you dissolve, there is no sugar is seen. Sugar is dissolved in the water. Once it is dissolved, it is homogeneous. That is what is called as, you like this? You like this slide? Okay. Now, once it is dissolved, how much solute is present? That has to be expressed in terms of percentages, in terms of molarity, in terms of molality, in terms of mole fraction. Okay, we are going to hack that now. Now, homogeneous mixture, you take this liquid benzene and you dissolve in toluene. What happened? It is going to dissolve without any disturbance, and it is going to give a clear uniform throughout solution, is called as homogeneous mixture. Rather, if you put some coconut oil in the water, it is not a homogeneous mixture, that is going to be heterogeneous mixture. So heterogeneous mixture is a mixture that has a non-uniform composition, meaning that composition of various form one part to the another. Okay, one part to the another. Are you getting or not? And here you can see some you have a boost and there is a milk, and if you just see suspension and colloids are the example of the mixture, you can see this. And if you dissolve some sand in the water or boost in the water, it is going to form a unclear mixture, that is called as heterogeneous mixture. समझ में आ रही है? So in order to say a solution, it should be homogeneous, my dear students. Heterogeneous mixture, यहाँ पे भी you just add oil in the water. And I keep asking doubts. So the team is working on that to make this great animation. So here you can see there are two layers that is going to be formed once it is added. So oil is added to the water, so oil is floating on the surface of the water. That is called heterogeneous mixture. Are you getting or not, bacho? You like it? And talking about homogeneous mixture, if the homogeneous mixture has only one phase, it is visible, and it is the uniform composition and the properties throughout, it is called as homogeneous mixture, and it is usually transparent, can be colored also. Okay, and when you dissolve a sugar in the water and mix it and keep it like that, sugar and water cannot be separated, they will be stable as it is. This is about a homogeneous mixture, identifying the solute and the solvent. How do you identify solute and solvent? You tell me. And a solute and a solvent, you have the solute and the solvent, different phases and the same phase. In the different phase, the phase of the solvent is the phase of the solution, mind it. That's the reason why gaseous solution, solvent is a gas, liquid solution, solvent is a liquid, solid solution, solvent is a solid. Okay? And also in same phase you have the component which is more in the amount is called solvent, and the one is dissolutes is called solute. The one which is dissolving is a solute, the one which is getting dissolved is a solute, the in which the dissolution takes place is called a solvent. Okay? And the components of a solution solvent, you have more amount, you have high dielectric constant, and represents the phase of the solution. Is very important. ठीक है बेटा? Anisha, you like the slides? You like the slides? Now, components of the solution, solvent, you have less amount, solute, this is solute. And you have low dielectric constant. Talking about identifying the solute and solvent in each of the following solutions. 80 grams of acetic acid, 60 grams of water, it is going to get aqueous acetic acid. Now, this is going to be 80 grams, 80 divided by 60 is the molecular mass of acetic acid. Okay, 60 divided by 18. So, number of moles you have to calculate it. When you talk about the number of moles, what is, yes, Anisha, you tell me who is a solute and who is a solvent in that? 80 grams divided by 60 grams comes to be 1.3 moles. It is going to be 1.33 moles. 60 divided by 18. So, 60 divided by 18 is going to be 3.33 moles. It is going to be 3.33 moles. I want to say which is present in the less moles. It is less moles. So, it is said to be solute. Okay, this is said to be solvent. I want to say it is also liquid, na? It is also liquid, na? So, the one which is present in the less, water is solute, no? Water is solvent. वाटर इज सॉल्वेंट. नंबर ऑफ मोल्स जिसका ज़्यादा होता है सॉल्वेंट है, नंबर ऑफ मोल्स जिसका कम होता है सोल्यूट है. वेरी इंपॉर्टेंट इंटरप्रिटेशन. 100 grams of sugar, 100 grams of sugar means C12H22O11. It is going to be 342. Molecular mass is 342. 100 by 342, okay, is going to be 0.3. 0.3 moles, actually 0.29 moles. 100 grams of water, it is going to 5 moles, 5.5 moles. 100 divided by 18 is equal to 5.5 moles. So, it is going to be 5.5 moles. So, it is going to be solvent, it is going to be solvent, it is going to be solute. Understand better? It is going to be solute. Any doubt? Identifying a proper solute, a proper. So, this is as absolutely a simple point, and students usually don't bother about this. But the question is going to be asked in such a way that the mole fraction of the solute it is asked. Then how do you say? You are going to get absolutely a reverse answer if you don't have the clarity. Okay, Anisha, you understand how to identify solvent. Solvent which has a less number of mole, solute which has less number of moles. Yeah, Anisha, fine. Got it? Clear? Now, let's talk about how to express the composition of the solution. How much solute is present in the solution is expressed in various ways. One is a composition of the solution can be, the composition of the solution can be described by its concentration. Okay, the concentration can be measured by using various formats. First one is a percentage composition. So, that is weight percentage weight volume percentage and volume percentage. And it is going to be weight percentage, mass of the component in the solution and total mass of the solution. Okay, and weight volume, that is the mass of the component of the solution upon total volume of the solution, and volume of the component upon total volume of the solution. These are the three versions. And of course, my dear children, here I just want to say it is temperature independent. And these two are going to be temperature dependent. Okay, now here it is going to be three versions. Mind it, it is really useful in calculation. And if you understand this formula, you can decode molality calculations, mole fraction calculations, especially these two. ओके, डेंसिटी से वॉल्यूम भी निकाल सकते हैं. ये डेंसिटी से वॉल्यूम निकालने के बाद मास ऑफ द सोल्यूट, मास ऑफ द सॉल्वेंट भी निकाल सकते हैं. दिस इज़ वेरी इंपॉर्टेंट. बच्चों समझ में आ रहा है क्या? क्लियर. सो फाइंड द वेट एंड वेट वॉल्यूम. बेंजीन 10%, so benzene in toluene. So if it is density is given, from the density you can calculate. Okay, calculation 10% weight by volume solution means grams of benzene in milliliters of the solution. Here this is density of benzene. You can calculate from the volume of the benzene, you can calculate volume percentage भी calculate कर सकते हैं. Okay, and talking about weight, other concentration, let me just give you the overall picture about the other concentration terms as well, then we can go ahead with your numericals, right? Other concentration terms. So students, are you able to follow here? Anisha? Okay, probe, you are asking about molarity. I am going to discuss molarity now for you. Aish Kumar, hi. So other concentration terms, we have molarity, we have molality, we have normality, we have ppm, we have mole fraction. So let us just, these are the just formulas I wanted to give you. Molarity is the number of moles of the solute present in a liter of solution, and molality is the number of moles of solute present in a kg of solution, and normality is number of moles of the number of gram equivalents of solute present in a liter of solution, and ppm, so number of parts of the solute present in a million parts of the solution. Okay, and mole fraction, it is the ratio of number of moles of a component to the total number of moles. So let's talk about 4 gram. Okay, okay, let's come to this here. So mass percentages, let us go in a systematic way. Mass percentages, mass of a solute upon total mass of the solution. Okay, that is called mass percentage. This mass percentage is said to be W by W percentage. You see, this symbol can tell you what it is, right? And another one, a solution is prepared by adding 2 grams of a substance of A and 18 grams of water. Calculate the mass percentage. Mass percentage, W by W percentage, is equal to 2 gram upon 2 plus, and it is dissolved in 18 grams into 100. Okay, that is 2 upon 20 into 100. Okay, it is going to be 1 by 10, it is going to be 10%. Are you getting or not? Clear? Like that you can do it. It is going to be 10%. Clear? Any doubt? Any doubt? Similarly, mole fraction, it is the ratio of number of moles to a particular component to the total number of moles. So it is the ratio is a total A component and B component is there. Generally, A we just say as a solvent and B we say as a solute. Now, here you can say mole fraction of A is equal to number of moles of A upon number of moles of A plus B, and mole fraction of B is equal to number of moles of B upon total number of moles. You want to take the sum of number of moles of mole fraction of A and mole fraction of B, it is going to be 1. Solutions and colligative properties, 12th standard you have this uses in lot many times. Okay, sum of the mole fractions is always equal to 1, and it is mole fraction is temperature independent. Temperature independent, my dear students. If 4 moles of alcohol, 6 moles of water are mixed, so calculate the mole fraction of the component. Mole fraction of alcohol is equal to 4 upon 4 plus 6. Okay, 4 by 10 is the answer. 2 by 5 is the answer. Got it? And molarity, here now we are talking about the molarity. It is the number of moles of a solute upon volume of the solution in liters and expressed in mole per liter. Okay, here temperature dependent. It is temperature dependent. Okay, now you can calculate in the various formats. So generously you say molarity is equal to number of moles of the solute upon volume of the solution expressed in liters. So it is equal to N into 1000 by volume in expressed in milliliters. Okay, you can say molarity is equal to weight of the solute by gram molecular weight into 1000 by V in milliliter, V in milliliters. Okay, so like that this is going to be used several times generously. Okay, several times generously. Are you getting or not? Clear? Any doubt? Molarity is temperature dependent, and the molarity can be calculated by mixtures, and this is going to be again our content department is done, and this is the volume V1. Okay, and this is the number of moles, molarity is M1, and if you add water, the water is going to be increased its volume, and it is going to be V2, and it is going to be M molarity changed, M2. This is called dilution. This is called dilution law, and number of moles are constant. Molarity is equal to N by V. Okay, if N is constant, MV is going to be constant. So when NV is constant, M1 V1 is equal to M2 V2. Are you getting or not? Clear? Any doubt, bacho? This is for dilution of the solutions. Any doubt? Any doubt? Anisha, want your response? Any doubt? Dilution of the molarities on dilution. Now let us come back to what exactly when solutions are mixed. So for mixing of solutions, you can see this is a solution A whose molarity is M1 and volume is VA, MA and VA. Okay, and it is mixed with solution B, and molarity is MB and volume is VB. Now I wanted to make it a mixture. Now this is a mixture, right? So the mixture is going to be, molarity of the mixture is going to be MAVA plus MBVB upon VA and VB. This is very important. And the previous one is dilution. When you go ahead with your dilution, how much water is added? Volume, how much water is added? How do we calculate? You all tell me how much water is added. Volume of water added is going to be V2 minus V1. That's important. V2 minus V1. And here for the dilution, it is going to be molarity of mixture is equal to MAVA plus MB VB upon VA plus VB. Okay, right? Now calculate the molarity of aqueous solution prepared by dissolving 4 grams of sodium hydroxide. So the molarity is equal to weight of the solution solute upon molecular weight into 1000 by volume in milliliters. Okay, this is the generous formula, we can use it, and it is going to be 4 grams. Molecular weight of sodium hydroxide is 40. Okay, it is going to be 40 into 1000 by V milliliter is equal to 250. So that is going to be the answer. Got it? It is going to be 0.4 mole per liter. Got it? Any doubt? The number of glucose molecules present in 10 milliliter decimolar. The term decimolar is what? A molar solution. You can solve it. Okay, a molar solution. A molar solution. The meaning of a molar solution means molarity is equal to 1. Okay, if the question says a semi-molar solution, semi-molar solution, and the molarity is given as a 0.5, or you can say m by 2, the terminology is m by 2. A decimolar solution, which indicates the molarity is equal to 0.1, or you can say m by 10 solution. Okay, and also you can calculate this, and well, let's talk about molality, another one. Molality, yeah. Aliza Pandey, I accept your answer, that's correct, and let me give you the content, then we can go ahead with the questions. Okay, Aliza Pandey, right? Molality is the number of moles of solute present in 1 kg of solvent. पिछले वाला जो है ना, a liter of a solution here in a kg of solvent. It is given as denoted by m, and it is unit molality is mole kg inverse, and it is going to be temperature independent. It is temperature independent. Okay, it is the number of moles of solute present in a mass solvent. Okay, so molality is small m, weight by gram, molecular weight into 1000 by weight of solvent expressed in grams. Okay, this is very important. Okay, sometimes okay, no problem, you can just present your answer. Here molality of 2% NaCl, this is very important question. It is a very important question. So weight of sodium chloride is going to be 2 grams. Okay, per cent na, you can say weight of solution is equal to 100 grams. Percent ka diya na, percent ka diya na. So weight of solute plus weight of solvent, weight of solution is equal to weight of solute plus weight of solvent. So weight of solvent is equal to weight of solution minus weight of solute. Simple. So whenever you are doing a numerical, solve the numerical with a lot of confidence and a lot of simple methods. I am writing this for working sake, for your understanding. I can say 100 minus 2 is equal to 98, I can say that. But I want to say the students should learn from the scratch level, marks muft mein nahi milta. Okay, so weight of solvent is equal to 100 minus 2 is equal to 98. Now you can say molality is equal to weight by molecular weight into 1000 by weight of solvent. weight is equal to 2 by 98 into 1000 by weight of solvent is going to be 98, and a molecular weight of sodium chloride 58.5. It is going to be 58.5. That is our answer. So the answer comes to be, what is our answer, Aliza Pandey? It is going to be 0.35 mole. Okay, got it? Now, volume strength of hydrogen peroxide, okay, that's equivalent weight. Oh yeah, equivalent weight is very important in normality padhana ke liye. And everybody understand the molarity, molality, mole fraction, but the thing is normality. So equivalent weight means it is the equivalent weight of an element, means atomic weight of an element by valency. Equivalent weight of a substance is defined as the number of parts by weight of it that will combine with or displace 1.008 parts or gram of hydrogen, or 35.5 grams of chlorine, or 16 grams of oxygen. Okay, so that is all about equivalent weight. So some element may possess the different equivalent weights because the valence is a variable. It is not constant for all the way. And equivalent weight of an ion can be calculated. Ionic weight by charge magnitude of the ion. That can be used for the salt as well. Now you can equivalent weight of an acid, that is the molecular weight of an acid, the basicity upon basicity of the acid. But so what is the meaning of basicity of the acid? It is the number of Hu plus ions that can be given by one molecule of an acid, like HNO3. HNO3 ionizes to gives rise Hu plus and NO3 minus. So equivalent weight, basicity, N is equal to 1. Okay, so you can say H2SO4, very very important. Now the complications will come, 2H plus and SO4 2 minus. So N is equal to 2. When you talk about H3PO3, H3PO4 gives rise 3H plus and PO4 3 minus. So N is going to be 3. So like that you need to calculate. When it comes to the phosphorus, phosphorus oxoacids will have the variable like H3PO3, H3PO4, H3PO2, different structures will be there and different basicities will be there. We will discuss about this in the P block elements. Okay. So equivalent weight of a base is the molecular weight of the base upon acidity of the base. So acidity of the base means number of OH minus that can be given. So that is number of OH minus ions that can be donated. So that can be given as sodium hydroxide gives rise sodium plus and OH minus, that is called acidity of the base, and calcium hydroxide gives rise calcium 2 plus and 2 OH minus. So you can say N is equal to 2 over here. Understand? Clear? That's good. Now talking about the normality, equivalent weight of a salt, formula weight upon total magnitude of the either cation or anion, you can take it. Like you say sodium chloride, okay, sodium plus and minus, so N is equal to 1. You can say Al2SO4 thrice. If that is the case, N is equal to 6. Right? So the total magnitude of either cation or anion, plus 3 into 2 is equal to plus 6. Are you getting or not? Or minus 2 minus 2 into 3 is going to be minus 6. Like that you need to take care of that. So equivalent weight of a salt or equivalent weight of the cation plus equivalent weight of anions. Okay. Normality. So normality is also temperature dependent. It is also temperature dependent. And it is the number of equivalent of a solute present in a liter of solution. That is given as unit is equal to gram equivalent per liter, and normality is calculated as number of gram equivalents of solute upon volume of the solute. So it is normality, I want to write it here, is equal to weight of the substance by gram equivalent weight into 1000 by volume in milliliter. This is the perfect one. Then how to calculate gram equivalent weight? So you can see normality is equal to weight by gram molecular weight upon n factor into 1000 by V in milliliters. V in milliliters. Okay. So if you take this, the entire scenario is coming to be molarity. It is coming to be molarity. Okay. So that if this divided by n comes here, na, so normality is equal to molarity into n factor. This is a super awesome formula. Are you getting or not? Any doubt? Any doubt, bachcho? Now it is dependent on temperature. I already mentioned you guys. Now I just want to say normality is equal to molarity into n factor. N is a valency factor. Different substances will have different n factors. Number of equivalents is equal to number of equivalents of other reactants. This is called VA, NA is equal to VB, NB. That is called, this is called as law of equivalence. This is called as law of equivalence. So A stands for acid, B stands for a base. If the number of equivalents of an acid is equal to number of equivalents of a base. And you can also use this. And also I want to say here, for dilution, you have the for dilution. You can use V1, N1 is equal to V2, N2. For mixture, normality of the mixture is equal to N1 V1 plus N2 V2 upon V1 plus V2. This can help you for acid base reactions. I just want to say you the acid base reactions parameters also. Okay. So when you go the calculations with pH calculations, you are going to come across with this. I'll tell you mole fraction, we did it. I'll tell you interconversion of concentrations, relation between normality, molarity, relation between molarity and this one. Okay. Molarity and normality. You can see here, normality is equal to molarity into n factor. That's it. If n factor is 1, it is equal to, if n factor is 1, normality is equal to molarity. Okay? And carefully you see here, if an acid and a base is mixed together, if acid and a base is mixed, this is very important. Let normality of acid is Na, volume of an acid is Va, and normality of base is equal to Nb, volume of base is equal to Vb. So, Na, Va and Nb, Vb are given. Now, the story comes. The story is given as Na, Va, Nb, Vb. If they are mixed, there are three things I just want to say. If Na, Va is equal to Nb, Vb, what is the nature of solution? A is an acid, B is a base, right? And if Na, Va is greater than Nb, Vb, if Nb, Vb is greater than Na, Va, so what to do this? If Na, Va and Nb, Vb, these magnitudes can help you to say this acid is completely neutralized by base, bacho, that's very important. The solution is going to be neutral. pH is equal to 7. Okay, that's very important. Now, acid jeet gaya, so that the solution is acidic. इसका pH लेस देन 7 होगा, इसका pH लेस देन 7 होगा. So you can say the H plus concentration is going to be Na, Va minus Nb, Vb upon Va plus Vb. This is very, very, very important. And what happens if the Nb base जीत गया यहाँ पर? अगर base जीत गया तो क्या करना? The solution is going to be basic. If the solution is basic, इसका OH minus calculate करने के लिए OH minus can be calculated Nb, Vb minus Na, Va upon Va plus Vb. Okay, now in this case you can say take the H plus, you can calculate pH. pH is equal to negative log H plus. Take OH minus and you can calculate POH. pH plus POH is equal to 14. So that pH is equal to 14 minus POH. Understand? Clear? Any doubt? So please ask any doubts, my dear children. Anisha, fine. Now I want to just mention what is the relation between density and molarity. Very important. Density and molarity. Right, beta? So here molarity is equal to density into percentage into 10 by gram molecular weight. Okay, this is a super powerful and simple formula I can say. So M is equal to molarity and D is equal to density and percentage weight volume percentage, and here GMW gram molecular mass, gram molecular weight. Understand? Clear? And it gives a lot of insight. So these are the simple things I just want to say. And when you see the various types of concentration terms that we learned so far here, I want to take you, the temperature dependence is very important here. Look at this, my dear children, temperature dependence. yes, here the temperature dependence, mass percentage or weight percentage, temperature independent or temperature dependent? Temperature dependent or independent? So it is going to be temperature independent. Mole fraction, temperature independent. Clear? And molarity, temperature dependent. Molality, temperature independent. Normality, sorry, temperature dependent. Molality, temperature independent. Normality, temperature dependent. And parts per million, it is going to be temperature independent if you take the mass. If you take the mass. Now, based on this, so far, even in the CBSE, the questions has been asked. Mind it. Majorly, molality and mole fraction are preferred because during a chemical reaction, temperature dependency is very important. So, to make the reaction, the calculation so precise, we use this temperature dependency as well. Okay, now my dear students, if mole fraction is given, you can calculate molality, and molality is given, calculate the mole fraction from the molecular mass of the solute and solvents. You can use it, and you can have three types of weight, volume percentages, and weight percentage, weight, volume percentage, volume percentage. Okay, and also you can say conversion into the normality into molarity. Okay, normality is equal to molarity into n factor. Finding n factor plays a crucial role in deciding that, and most of the calculations lies here and here and here and here. And normality, as far as the CBSE part is concerned, it is given less emphasis. When it comes to the NCERT and NEET examination, normality is taken in the highest criteria of the importance. Okay, now today we are done with concentration terms. In the next class we will be discussing about the stoichiometric calculations and the empirical formula and the molecular formula. And hope you love this session, and please like this session, share with your friends, and subscribe to Infinity Learn NEET YouTube channel. Thank you. Signing off, Suresh, Faculty of Chemistry. Bye bye.